Welcome to this deep dive into the world of open educational resources and, more specifically, open source physics.
Okay.
We're going to be looking at this website
Right.
called Open Educational Resources, Open Source Physics at Singapore,
Right.
which is like treasure trove of simulations and tools and even lesson plans, all
Wow.
freely available.
That's amazing.
And when I say a lot, I mean like the tags alone range from quantum physics to numbers up to 100.
Oh,
So
wow.
yeah, suggesting a pretty vast scope.
It is fascinating to see such a diverse collection in one place.
Right.
And, this points to, I think, a broader trend of making physics education more accessible,
Yeah.
which is particularly important for a subject that often relies on, visual aids and hands-on experiments.
Absolutely.
So,
Yeah, and it's not just static resources either.
yeah.
I noticed an event listing for something called the 21-5-205 SUTD Active and Interactive Pedagogy Series, Peter Dourmashkin.
Okay.
Interactive pedagogy, especially in physics, sounds like it could be a real game changer.
It really can be.
Yeah.
Think about it. Traditionally, physics education has involved a lot of lectures and textbook learning.
Right.
Interactive pedagogy kind of flips that script, right? Puts the student at the center.
Yeah.
Allows them to experiment, explore, and really grasp those aha moments through that direct interaction with the concepts.
That makes a lot of sense, and it seems like there's a real appetite for this kind of approach.
Mm-hmm.
The website boasts over 1,170 articles with almost 10 million views.
Wow.
That's
Impressive.
yeah, pretty strong indication that these resources are resonating with people.
Those numbers are quite remarkable.
Yeah.
They really highlight the growing demand for open source physics education.
Right.
And not just from students, but likely from educators who are seeking, more engaging ways to teach.
Yeah, for sure.
And this kind of widespread access can really democratize learning,
Mhm.
especially for those who might not have those traditional resources available.
Absolutely. Something that caught my eye was a Dropbox link
Okay.
for a simulation file named EjsS model shm13.zip.
All right.
Being able to just download and run a physics simulation on your own computer feels very different
Right.
from just reading about a concept in a textbook.
Absolutely. And that hands-on aspect can be a huge advantage for learning physics.
For sure.
Simulations allow students to visualize and manipulate abstract concepts
Right.
in a safe, controlled environment. You
Yeah.
can explore things that might be, too difficult or expensive or even dangerous
Right.
to replicate in a real-world lab setting.
Yeah. I'm also seeing a lot more than just simulations listed here.
Yeah.
Workshops, lectures,
Okay.
even modeling tools. It seems like this website is trying to create
Yeah.
a holistic learning experience for anyone interested in physics.
It's more than just providing tools. It's
Yeah.
about fostering a community. Educators can share lesson plans. They can modify existing simulations.
Yeah.
Collaborate on new approaches. This open exchange of ideas can lead to some really innovative teaching methods
For sure.
and a richer learning experience overall.
All right, let's get a bit more specific.
Okay.
Some of these titles really jumped out at me.
Right.
Big Dang Legends by Lightyear sounds pretty intriguing.
Mm-hmm.
Then there's Tamil Primary 1A, Lesson 3, HTML5 JavaScript Interactives.
Yeah.
Obviously targeted at a much younger audience.
Right.
And then Investigate Busted, Bungee Jump Tracker at Evergreen Sec. Definitely piqued my interest.
It's amazing to see the breadth of applications here.
Yeah.
From exploring the origins of the universe to teaching basic concepts in different languages.
Right.
Open source physics can be applied in incredibly diverse ways.
Yeah.
The bungee jump example is a great illustration of how these tools can make learning fun and relatable.
Yeah.
Imagine being able to analyze the physics of a bungee jump using real-world data.
Right.
It brings the concepts to life in a way that traditional textbooks often struggle to do.
Absolutely. And it's not just individuals driving this. Organizations like the Science Teacher Association Singapore and the Ministry of Education are also involved in promoting these resources.
That's a significant point.
Yeah.
Having institutional support can really accelerate the adoption of open educational resources.
Mm-hmm.
It lends credibility to the movement
Right.
and can encourage more educators to explore the possibilities of open source physics.
Yeah.
It's about creating a system where high quality educational content is freely available to anyone who wants to learn.
So we've established that this site has a vast collection of resources and is backed by some serious institutions.
Right.
But what are the practical implications for someone actually trying to learn physics using these tools? Let's delve into that in the next part of our deep dive. Let's kind of shift gears a bit and talk about how these resources actually translate into
Okay.
practical learning experiences.
Right.
We touched on the Investigate Bungee Jump Tracker at Evergreen Sec project earlier.
Right.
Can you tell us a little bit more about how something like that might work?
It's a great example of bringing physics concepts to life.
Yeah.
Imagine a group of students, filming a bungee jump
Right.
and then using a tool like Tracker to analyze the footage.
Tracker being that open source video analysis tool we mentioned.
Exactly.
Okay.
With Tracker, they can track the jumper's position, velocity, and acceleration throughout the jump.
Wow.
This allows them to go beyond just, theoretical calculations
Right.
and see how these concepts play out in a real-world scenario.
So it's like taking the experiment from the textbook
Yeah.
and putting it into action.
Exactly.
Using real data that must make a big difference in terms of understanding.
It's a completely different level of engagement.
Yeah?
They can test hypotheses,
Right.
see the effects of gravity and energy transfer firsthand,
Mm-hmm.
and even explore the spring-like behavior of the bungee cord itself.
And I imagine the learning doesn't stop there.
Right.
They could potentially take that data and use it to create simulations, right?
Absolutely. They could build a virtual bungee jump using other open source physics tools,
Right.
and then tweak variables like the jumper's mass or the cord's elasticity
Got it.
to see how it affects the jump.
Wow.
It becomes a dynamic exploration rather than just a static problem on a page.
That kind of flexibility and experimentation is really exciting.
Right.
It seems like a much more active and engaging way to learn physics.
Yeah.
But let's zoom out for a moment.
Okay.
We've been focusing on the student experience.
Right.
What about the educators using these resources?
Yeah.
What kind of impact are they seeing in their classrooms?
There's a real sense of empowerment there. Instead of being bound by a textbook,
Right.
teachers can curate content from a vast library of resources
Yeah.
and tailor it to their students' needs and interests.
Wow.
They can incorporate simulations,
Right.
real-world examples like the bungee jump project,
Yeah.
and even adapt materials for different learning styles.
It sounds like it encourages a much more creative and dynamic teaching environment.
Precisely.
Yeah.
Open source physics allows teachers to move away from rote memorization
Right.
and towards a deeper understanding of those underlying principles.
For sure.
They can focus on helping students develop critical thinking skills, problem-solving abilities,
Mhm.
and a genuine passion for physics.
We've talked about simulations quite a bit.
Yeah.
I'm curious, what are some of the other types of resources educators are using?
There's a huge variety.
Okay.
Some are using interactive whiteboards to visualize concepts.
Right.
Others are incorporating coding exercises to build simple physics models.
Wow.
There are online communities dedicated to sharing lesson plans and best practices, and platforms for collaborative research projects. It's really a vibrant ecosystem of learning and teaching.
It's incredible to see how this open approach is transforming physics education.
Yeah.
It's making it more accessible, engaging, and relevant for both students and educators.
And it's not just about the tools themselves.
Right.
It's about fostering a culture of collaboration where knowledge is freely shared and everyone has the opportunity to contribute.
Yeah.
That spirit of openness is what makes this movement so powerful.
So we've covered a lot of ground, from the practical applications of open source tools to the broader impact on the learning environment.
Yeah.
But there's one more key aspect we need to explore. The role of technology in shaping the future of open source physics.
All right.
Let's dive into that next. We've talked a lot about the what and the how of open source physics, but I think it's also worth considering the where, as in where is all of this headed?
Yeah.
Technology is constantly evolving. So what role do you see it playing in the future of this movement?
That's a great question. And I think the potential impact of technology is huge.
Yeah.
We're already seeing virtual reality and augmented reality
Right.
starting to be used in education.
Yeah.
And I think those tools could be particularly powerful for teaching physics.
I can see how that would be amazing.
Yeah.
Imagine being able to actually walk through a virtual atom or manipulate a virtual model of the solar system with your hands.
Right.
It takes that hands-on learning to a whole new level.
Exactly. And as these technologies become more affordable and accessible,
Yeah.
I think we'll see them being integrated more and more into open source physics resources.
Right.
It could really revolutionize the way students learn and interact with complex concepts.
It's not just about fancy visuals, though, right? There's also the whole aspect of data analysis and computation, which is becoming increasingly important in physics.
Absolutely. Open source tools are already playing a big role in that area.
Yeah.
There are platforms for sharing large data sets,
Okay.
collaborative coding environments, and
Right.
even cloud-based simulations that allow researchers to run complex experiments
Wow.
without needing access to, expensive supercomputers.
It sounds like open source is not only changing how we learn physics,
Right.
but also how we do physics.
It's true. By removing those barriers to access and encouraging collaboration.
Right.
Open source is really accelerating the pace of discovery in physics.
That's incredible.
It's allowing researchers from all over the world to work together, share data, and build on each other's work in a way that was never possible before.
So as we wrap up our deep dive,
Yeah.
what would you say is the biggest takeaway for our listeners?
I think it's about recognizing the power of openness.
Okay.
Open source physics is more than just a collection of free resources.
Right.
It's a philosophy,
Mhm.
a way of thinking about knowledge and education
Yeah.
that can be incredibly empowering.
Right.
Whether you're a student, a teacher, or just someone who's curious about the world, there's something out there for you.
And more than that, you can be a part of it.
Exactly.
You can contribute, you can collaborate and help shape the future of how we learn and explore the universe around us. It's a pretty exciting time to be interested in physics.
I completely agree. And who knows what amazing discoveries and breakthroughs are waiting to be made,
Yeah.
thanks to the power of open source and collaboration.
That's a great note to end on. Thanks for joining us for this fascinating deep dive into the world of open source physics.